This project is based in Black Rock Desert, Nevada as a festival pavilion for Burning Man. The biopolymer is the primary material in this pavilion design, and helps combat the chemical burns experienced by festival goers by neutralizing the basic properties of the site's dirt. Panels come together in the desert to form an open-top pavilion for visitors to enjoy protection from the wind and sun exposure. The wall wraps around the site, peeling out at one end to allow visitors to walk and experience the double wall condition. The panels form a modular system, where each panel block interlocks with another to form a puzzle piece design. The panel-to-panel gap allows a small degree of bending for a simple curved surface when all panels come together. A base wooden frame creates the shape and structural rigidity for the cast biopolymer sheet to spread over. Robotically extruded 3D printed toolpaths layer on top of the cast formwork at 4 mm apart. Through style transfer programs, satellite images were combined to create unique forms for the toolpath design. The toolpath patterns are derived from the generated landscape textures. A range of color palettes was also selected to reinforce the project's vision. Blues and greens introduce cool tones to a desert environment. A mixture of the biochar black base and translucent patterns create contrasting backgrounds that help these colors stand out. Biopolymer derives from naturally sourced materials based on a composite of glycerin, vinegar, arrowroot powder, potato starch, and water. We tested additives for structural resilience, design aesthetic, and a clear origin based on their qualitative properties. A range of textures, colors, grain scale, strengths, and translucencies was examined. Sand retained the sample's size and shape but produced lots of cracking, likely due to its loose property. The locality of the material made it ideal for the project's leave no trace behind concept and essential biodegradability. Biochar's high color contrast, no cracking, and high degree of flexibility made it a great base. However, the additive showed the most shrinkage from its original size. Paper pulp provided a balance of flexibility and torsional strength, as well as retained the sample's original size. Sawdust created a highly textured sample, but it provided little to no structural rigidity. Iron oxide gave a rich red color, but cured with large cracks in the sample. We extruded with a base layer of biochar and top layers of dyed paper pulp for rigidity and visual impact. These additives allowed us to create visually vibrant color contrasts while retaining the flexibility and stiffness needed for the biopolymers to mount over the panel frames. Each week requires planning for the production of the biopolymer panels. Making the biopolymer starts with cooking arrowroot powder, potato starch, vinegar, and glycerin in a pot of water over a stove. Once the mixture reaches 150 degrees Fahrenheit, it is cooled to room temperature. Additive materials of biochar and paper pulp form the two biopolymer bases. 1. The base biochar composite is a mixture of biochar, paper pulp, and biopolymer. This composite is cast into 26 Inkex 18-inch baking sheets and baked at 140 degrees Fahrenheit for 4 to 6 hours, flipped halfway until the sheet is dry to the touch. The biochar is then mounted to wood panel frames and secured by upholstery staples and glue to adopt the form's shape. 2. The toolpath layers are a blend of paper pulp, color dye, and biopolymer. They are extruded by the robot above casted biochar formwork. A top layer toolpath extrudes 4 mm above the first layer to create an intermixing of colors and a tie-dye effect.